Welcome to another Electronics and More video. In today's video, I'm going to be showing you another extremely useful piece of test equipment known as a Megger or insulation tester. I'm actually going to be showing you two types. One is mechanical that you crank, like you see right here, and the other is electronic. It can test using higher voltage and has multiple functions. This crank Megger, purchased at a Goodwill store, and the electronic version can be purchased at the link shown in the video description area. If after watching this video you're interested in the less expensive crank Megger like you see here, I'm going to be placing a link to the crank Megger in the video description area. This electronic version is ideal for electricians, HVAC technicians, appliance repairmen, or any other professionals that have a need to test windings or wires on a daily basis. Just like my other videos, you'll be supporting my channel with your purchase, and you'll also be saving money by using the coupon code supplied in the video description area. Let's get started first with the crank Megger. First, I'd like to discuss how a Megger works and why it's different than an ordinary ohm meter. Meggers, or insulation testers, are designed to measure the resistance between a wire and the insulation of that wire. It can be insulation on a wire like you see here, or it can be enamel wire, which is used inside motors, relays, and transformers. You want to make sure the resistance is as high as possible between the center conductor and the outside of the insulation. Some of you may say, why not just use an ohm meter like you see right here? And the reason being is if you use an ohm meter, it's only going to be checking the wire or the windings of a motor using very low voltage of around 9 volts. The Megger is going to be using a much higher voltage. It's going to be using anywhere from 250 all the way up to 1000 volts, which is the electronic model. This one does 250 and 500. What the insulation tester does, it applies a potential or voltage to the wire or winding that's under test. And because you're putting pressure or voltage on that center conductor, if the insulation is deteriorated, cracked, dried out, and susceptible to the voltage leaking through it, by applying that higher voltage, it's going to show up. With a regular ohm meter like you see here, you're not going to be able to see that. And the easiest way to understand would be like a water pipe. So if you have a water pipe and there's no pressure in that pipe or very little pressure, what's going to happen, you're not going to notice any leaks on the outside of that pipe, even if the wall of that pipe is very, very thin in one spot. It may have a little tiny pinhole, or there's a fitting that's susceptible to leaking. You are not going to detect it. By applying water pressure to that same pipe, what's going to happen, you're now going to be able to see that there's a problem with that pipe and that it leaks. So this is basically the same as a Megger. One is using water pressure, and in this case, we're talking about current leaking through a wire. Okay, let's go take a closer look at the crank generator. This one here, like I said, I found at a restore in my area, which is a Goodwill store. Open this up right there, and you can see there's a display. Move back just a little bit. That's a 250 volt scale. This has two settings. This is a Japanese made Hitachi unit. 500 volts here, and look when this thing was made, 1959. Incredible, really old. The scale goes up to 50 megohm at 250 and up to 100 megohm 500 volts. There's the infinity line. Any readings above 100 would be probably into the thousands of megohms. On the back you have your output, positive and negative. It is a DC output that you're testing with. Over here in the front you have the crank. Now this particular unit has a built-in clutch. What's going to happen is designed, once you start cranking it at a fast speed, you're going to feel it slip. And that slip is intentional because that's what regulates the voltage output. If this didn't start to slip and you continued to crank faster and faster, the voltage would get higher and higher. So let me just demonstrate. I'm going to spin this by hand. You're going to hear how it operates, and then you're going to hear when it starts to slip. And you can hear it slipping right now. Now it's normal. See it's slipping, the handle's spinning faster, but the generator itself is not going faster. And that is how this particular type is designed. On the bottom, you have a selector switch, 250 volts or 500. Look at the bottom. Now generally, when you're doing testing, it's a good idea to test with a voltage that's twice as high as the voltage that's being used for a particular motor or heating element. So if you're going to be testing a motor that operates at 120 volts or a heating element, or you just want to check some wires out that are possibly grounding out, what you're going to do is you're going to set it to the 250 volt scale, which will be right here. If you're working on a 240 volt circuit, you're going to push it over to 500. Insulation testers are extremely useful, and as I said earlier, you can check motor windings, transformer windings, and if you're an electrician, if you're going to be pulling lines through a metal conduit, you may want to make sure that it's completely isolated from other wires within that conduit. You may also have a problem that in your electrical panel, one of the breakers keeps tripping, and it does not do it all the time. It could be an intermittent short circuit, and these are excellent for finding out which wire in that conduit is the problem. Anytime you have an intermittent problem, where breakers trip on and off sometimes, you're definitely going to want to inspect the circuit or the motor connected to that circuit using a Megger. The higher the voltage on a conductor, you're going to have more current leaking through the insulation. It is normal to have a very slight amount of current passing through the insulation at high voltage. You just don't want a lot of current, because if you do, what's going to happen, circuit breakers will trip. The reading that you're going to get on a meter like this will be affected by humidity. Low humidity will lead to higher resistance readings, and higher humidity leads to lower resistance readings. Temperature also affects the readings when using a Megger. Let me connect up a wire and show you how to check the insulation on a wire. What I did now is I connected up the output of the Megger to my digital meter on a DC voltage range. It's set for 250 volts. This is a 10 megohm input, so when I crank this up to a high speed, you're going to see the output voltage displayed right here, and right on the 250 volt scale, I'll tilt it, it's going to go right to 10 megohm. Here we go. See, it went right up to the 10. So this is very accurate. Let's put it up to the 500 volt range now. We're going to be looking at the lower scale here. So the 10 should show up here, and over here we're going to see 500 to 600 volts. If you shorted these two wires together, you would see that the needle would swing all the way to the right when you go to crank. So let me short those together, tilt it so you can see the meter, and crank it. And there you go, all the way down towards 0 ohms. I just wanted to show you that because you might say everything's coming out the same at the top. But as you can see, if the resistance is very low, this will swing all the way down. I'm going to take one of these, place it on the center conductor, like that. Make sure you do this on a non-conductive surface. You don't want to do this anywhere where it can affect the reading. So be careful when you do the reading, always on a non-conductive surface. Now I could just clamp this on the wire, but I don't want to damage the insulation, so I'm going to put a little piece of foil on the outside and then clamp it like that. Okay? Now I'm going to tilt this so you can see it. Put this on the 250 volt setting. Alright, it's on 250. If this wire had faulty insulation, you would see it swing all the way down over here on the 250 volt range to the 1-2 meg and below. So let's make sure it stays as high as possible. And you can see there's nothing going on. It moved back again. That's well above the 100 megohm. It's probably in the thousands of megohms. Now if I push it up to 500, let's see what happens. Same thing. Now we're going to take a look at a heating element. Like you see right over here, we're going to take one wire connected to one of the terminals, the other clamped on the outside, and we're going to see how well it's isolated between the tip and the outer jacket. Since this is a 120 volt heating element, I'm going to leave this on a 250 volt setting. We're going to crank it. You want to make sure that the resistance reading is well above 2 megohms. Here we go. And you can see there's not much going on with that one. It is a fairly new element. Let's put this to 500 now, see what happens. And you can see the 500 did cause a little bit of breakdown, but it was still well above the 100 megohm range, probably a couple of hundred megohm. Shortly I'm going to be repeating these tests using the electronic unit. You could test the condition of the windings within any motor. So we're going to be checking out this drill right here. So you push this over there. And what we're going to be doing, when you check these, you want to test between the ground and the neutral and the ground and the hot. So we take this over here, connect it to there, take that one to there. Make sure they're not touching. And make sure it's on a 250 because the drill is operated at 120. Give it a crank and it should stay fairly high. Alright. Now I'm going to go over to the other pin. If you saw the needle swing all the way down and it went towards the 2 area or lower, you're going to know you got a problem there, and that motor is going to be prone to failure in the very near future. Remember, you don't want to test between the neutral and the hot. You want to check between the neutral and the ground and the hot and the ground. If you have a problem with an AC compressor that tends to overheat or trip the breaker, you're going to turn power off to that unit, discharge the capacitor, remove the blade connectors from the compressor, and you're going to check between each one of the terminals and ground. You should have very high readings on the Megger. Now let's take a look at the electronic version. Okay, you're now looking at the UNI-T Model UT526 Multifunction Insulation Tester. The unit is very compact, unlike the crank Megger. These are the probes. See, the tip is mostly covered to protect you from the high voltage during the test. These also pull off on both sides, and then you could take right here and screw these on. Alright. Put that back. Over here you have a special cord This is an RCD cord. Remove these plugs, and I'll show you in a minute. This plugs into the unit for some testing. Now the end that was on here was a European plug, so I cut it off and made sure the American plug, like you see here, that the line, which is the red, was connected to the blade over here. The left blade I made sure was connected to the neutral, which is blue. Right there's the N. And then of course the green, which is the ground, goes to the ground pin. Let's open this up, take a closer look. On the side, you can see it's just a snap case. Battery cover behind here is 6 AA batteries. So open it, just pull this off. Put this under here so you don't have a glare. Now, unlike the crank Megger, not only is this unit a lot smaller, but it does go up to 1000 volts for the insulation tests. In addition, it also tests up to 500 megohm, unlike the crank generator, which only shows a high of 100 megohm. This unit does have multiple functions, even though I only use 2 or 3 of them. You can take this cord right here, and you can plug it in right over here, blue with the blue, red with the red, green with the green, and you can take a peek at the top right here, and you can see it says RCD and V for voltage, and over here where it says megohm, ohm, that's where you're going to be connecting the test leads to measure the resistance of the insulation. First, let's turn it on. On this setting right here, you'd be checking protective earth conductors for ground purposes. So this goes from 0 ohms all the way up to 2 kilo ohm. So if I wanted, I could easily check the resistance across this heating element. I'll show you that quickly. Once that's connected, you're going to push the test button, and you can see it's 11 ohms, this heating element, and the voltage during the test right now is at 1.79. So it's 1.79 volts measured across these terminals, and we have around 11.4 ohms. So not only would you use this for protective earth conductors, you can use it for measuring resistance up to 2 kilo ohms as well. This unit has the ability to measure up to 440 volts, AC or DC. It automatically identifies if it's AC or DC. And it'll also give you a frequency readout between 20 Hertz and 100. So you're going to put this to RCDV. This right here is trip current. This is another setting that I usually don't use. So you push this and hold this button. Take the connector, and you plug it into a receptacle, just like you see right here in this clip. Plug this into the receptacle. And now I'm going to push the test button. And you can see over here, 123 volts. It'll automatically detect AC or DC. And there's your frequency, 60 Hertz. Push the button, power it off, and unplug the receptacle. Also on the RCD setting is the other feature that I mentioned that I do not use, and that is for testing residual current circuit breakers, or GFCI type circuit breakers. What you do is you set the trip current. Here it's 10 milliamps. You can make it 30, 100, or 300. Once you have it set, you plug this end right here into an RCD protected branch circuit, push the test button, and then you wait to see if it trips. If it does not trip, then you're going to turn it off. You're going to increase to 30 milliamps, push it again. When the circuit breaker trips, it's going to display how many milliseconds it took for you to trip that breaker. It's a useful feature, but one that I do not use. Okay, now let's take a look at the Megger. We're going to put this to 250 volts. Over here is going to be your test voltage, and this is going to be the resistance in megohm. Before I perform a couple of tests, what I'm going to do is just connect it up to the meter, show you the voltage as well as the impedance of my digital meter. Now that it's connected up, what we're going to do is push the test button, The test will remain active until I push the test button again to turn it off. Over here, 250 volt test voltage. You can see this lightning bolt flashing, which means stay away from the wires as long as that's flashing. 250 and 9.9 megohm. That's the impedance of this meter. Push to stop. Now let's push it to 500. Try it again. We got 503, 503, 10 megohm, 10 megohm. Now let's take a look at the heating element. Take one, connect it to the terminal here. And we're going to take the other and connect it right on here. Then we're going to push the button right here, 250 volts. This is a 120 volt element. And you can see the test shows it's over 200 megohm. If you see an element that's down around 2 megohm or less, it's getting very close to fail, and you should definitely replace that element. Let's take a look at a wire. Here's the same test we performed earlier using the crank Megger. It showed well over 100. Let's push the test button. And this is saying it's well over 200 megohm at 250 volts. Let's switch to 500 volts just for the hell of it. Let's try it again. Here we go. And it's showing over 300 megohm at 500 volts. Let's go to 1000 on that wire. There you go. It's over 500. So the insulation on this wire is pretty good. Now let's take a look at the drill. Now we're going to test it on an electric motor. In this case, it's a drill. It could be a universal motor from a vacuum cleaner, compressor, electric motor for a swimming pool or a sprinkler system. Makes no difference. Just make sure you connect between the winding and the ground. I'm going to push the button. And that's over 200 megohm using 250 volts to test. Then you could flip it around this way. Take that, move it to the top, and repeat the test again just to make sure. There, it's active, and it's still the same. The best way to establish what a good reading is, or a normal reading is, would be to compare this reading to a new drill, or over time, every 6 months, take a reading from a new one, and see how it gradually drops and levels off. You want to do it over time. If you had to work on multiple AC systems in a building, then what you would do is you'd be able to compare all the compressor values. So you'd have all the different readings side by side, and if they're all the same manufacturer, same model, you'd be able to compare the insulation from one to another. If you don't have more than one, then you just want to make sure you have a high reading. At least 50 megohm or higher should be okay. As that number gets lower and lower, you know the life expectancy of that compressor is getting very close to the end. The last thing I'm going to do is show you how to do some tests on a breaker panel. Now, before any insulation testing takes place on a breaker panel, you have to ensure the branch circuit that you're checking, or even the feeds into the panel, if you wanted to check those, they must have all power removed. The circuit cannot be on, so you have to make sure you disconnect the wires from the circuit breaker if you'd like to check a branch circuit. Also, anything connected to that branch circuit must be removed from the electrical receptacle. So if you have a clock plugged in, a computer, or anything else, it must be removed from the circuit. If you have a GFCI, ground fault circuit interrupter, on that circuit, you're going to have to remove it from the circuit. You don't have to disconnect the entire thing. You can remove just one side, the hot or the neutral, just as long as it's no longer connected to the circuit, creating a loop. Any dimmer controls, any timer controls, they also must be removed. If you're experiencing a problem where one of your circuit breakers is tripping intermittently, and you have removed all the loads from that branch circuit and it continues to do it once in a while, then what you're going to have to do is just make sure that breaker is in the off position. You're going to remove the wires connected to the circuit breaker, and you're also going to remove the neutral wire connected to that circuit from the neutral bus bar. Once that's complete, you're going to take the black test lead from the Megger and you're going to connect it to the ground bar inside the breaker panel or to the breaker panel enclosure itself. You're then going to take the red lead and you're going to connect it one at a time to each one of the wires inside the conduit which was connected to the circuit breaker. When you take the readings, you're going to compare the readings on each one of those wires. They all should be very high readings. If you notice that one of the wires gives a lower reading than the other 2 or 3, then you're going to know that that's the wire which has the problem with the insulation, and you're going to have to replace that wire or inspect further from the panel to see what the problem may be. It's also an excellent idea to use a Megger when pulling a new wire through conduit into a breaker panel. So if you look at the top of the panel right here, you can see this metal conduit with the white wire and the black. If I pull through a red 12 gauge wire, once that wire is pulled through that conduit with the other wires, you're going to want to check that wire to make sure it's well isolated from the ground as well as the other wires in the conduit. So you're going to repeat the procedure. The black lead on the ground bar inside the panel or the enclosure. You're going to take the red lead and connect it to the red wire you just pulled into the panel, and you could set the Megger to 250 volts and perform the test. The reading you get should be a high reading. Once that test is complete, then you're going to disconnect the wires inside the conduit that are already there, which may be connected to a breaker. You're also going to disconnect the wires at the other end away from the panel where you pulled the red wire into the panel from. So when both ends are exposed, you're going to take the Megger and you're going to take a reading between the red wire you just pulled in and the black wire that you see here. You're going to take another reading between the red wire and the white wire you see here. Make sure the readings are all high. If they are, then everything's okay and you're good to go. I hope you enjoyed this video. If you did, please rate it a thumbs up, subscribe, and post links to this video on other websites and blogs. Also be sure to check out my video playlist as well. Thank you very much for watching.